My hat! Now the rotor that I'm testing right now is the 1154. So this is TEP1154 by Trinity, and it's in this 13.5. Now previously I tested this motor with the stock rotor, which is an 1119. The 1119 rotor is a 12.5 millimeter diameter rotor with approximately 1700 Gauss. This rotor that I've installed in this motor is 13.5 millimeters in diameter, and the Gauss is over 2200. So it's a very strong rotor. Now, I've mentioned this in some other videos. With rotors, the larger the diameter, the more torque, assuming it's a similar material. Well, let's just say it's the same Gauss. It's just larger. You have a larger lever arm, therefore you're going to have more torque. Same force, longer lever arm, more torque. Now here with this one, you have larger diameter, larger Gauss. The torque is going to be through the roof compared to some of the other rotors. So for example, the stock rotor, that 1119 rotor, that is approximately 1700 Gauss. That's quite a large difference. That's over 500 Gauss difference between the two rotors, and it's a millimeter difference in diameter. So you're going to get a huge performance difference there when it comes to torque. Now, not all applications are the same. This 13.5 millimeter rotor is probably not a rotor that you would want to run in, say, a slippery surface or low traction, such as dirt. Probably not. On a higher speed vehicle, say a two-wheel drive buggy or whatever it may be. You're probably going to be spinning out quite a lot. It's just too much torque, and you're going to have to do your gearing to make up for the difference to pretty much mechanically lower your torque. Now for a crawler, this is awesome. For a crawler, this is great. You want the torque, you want to go just slow and be torquey. So this is fabulous. No prep drag car, this is definitely something to consider for a no prep drag car. Now the timing, the spread is actually very good. The amps, it will consume a lot of amps. Keep in mind that the stronger the magnet, over 2200 Gauss, larger the diameter, more torque, it's going to take more amperage to rotate that rotor. So a few things that you're going to notice. Yes, you're going to notice a lot of torque, but you're also going to notice less kV. So you're going to end up having less top speed. Your RPM is going to be lower. But again, consider the Gauss difference, the diameter difference, and then choose your application. Maybe sometime in the future I'll make a video using Trinity's chart on Gauss and what the application should be. But again, a rotor like this, high torque application, high traction application, and you're probably going to compensate for the lack of speed with gearing. Well, let's go to the data table and compare. Now, in this table, I still kept this old Team Trinity information, so you can look at this table. In a previous video, when I originally bought the 13.5 motor with the stock 1119 rotor, I did a comparison, showed how, well, this one has less kV than that one, and I talked about how it could just be a rotor difference. And what happens with some manufacturers is they'll come out with a new version. For example, now we're on the V4. But really, you could have just kept your old version, just swap the rotor. Sometimes they'll just swap the rotor for performance reasons. So they'll go with maybe a smaller diameter for more RPM, larger diameter for more torque, or they'll go with something with more Gauss, less Gauss. So if you bought, for example, a Hobbywig Just Stock, I believe it's the no, not the Just Stock, their V version. They generally have rotors that are lower Gauss. So you're probably going to get more kV out of something like that. Whereas X Factor, these are pretty high. This one is rated at about 1700 Gauss. This is a small diameter. This one really revs. As I compared it in a previous video, this one's approximately 1400 Gauss, and this one is over 2200 Gauss. This one's plus or minus 2250, so over 2200 Gauss on this particular rotor. This is a 13.5. And I talked about how smaller diameter will generally give you more RPM, but less Gauss will also give you more RPM because it'll be easier for the motor to be turned, but you're going to be losing torque on that, so that's something to consider. This is probably not a rotor you want for a crawler or a drag car. Just throwing it out there. This is a good all-around rotor that you could use, but this one's insane. Now the KV is going to drop, and that's something that I want to show you. So 4.5. 4.5 is the closest thing we can compare to something else. So if we compare this to, keep in mind it's the same exact can, we just swapped the rotor, that's all. 4.6 kV is over 4000 kV on that small rotor versus this one 3000 kV. So we are looking at 3300 kV on this particular motor with this rotor. Now, this is something important to keep in mind. This is why, for example, for stock, no prep, generally it's 13.5 turn. Versus open, you will see people go down to 6, 4.5 turns or something. Because then you can add to this rotor more turns, speed it up, but be careful with the amp draw. Now on a drag car, you're not going to be running it for very long. Right? It's just a few seconds, say 3 seconds tops. Versus if you're doing a circuit, for example, on-road 5-minute race or off-road 5-minute race, you would destroy this motor. You would completely destroy the motor. So this is probably not something you want for long racing, just because of the amps. The highest timing, you would probably be around 35 timing. So 37, we're at 5.5, which is 3,367. And again, same exact can. Versus, well, let me do this comparison. This is 7.4, 3,500, so 3,500. And let's compare it to the stock rotor, 3,500. We're at 3.5. The motor's not really going to care. This motor is going to, if geared correctly, this motor is going to run as cool as can be, and your runtime on your battery is going to be very good. This is going to deplete your battery a lot faster. Now, let's see this. Let's see 4.1. So let's go to the stock. 4.1. Do I have something close? Not really. 4.9. 4.9 is close. 3,700 compared to 33 again. And the KV doesn't really increase, but what you are getting is you're getting a massive amount of torque. Now, given the torque that you are getting from this, now I don't have a dynamometer to test these motors as of this video, but one of the ways, and maybe at some point I'll do it when I swap into my DR10, you'll notice the acceleration when you take off. If you have a GPS unit, for example, a SkyRC that records your acceleration, you will notice it there. That's one way to measure it. You can use that device, put the motor, say, put this rotor or this rotor, drive the car, just make sure the surface is about the same, temperature, ambient temperature is about the same, fully charged battery every time. Compared to this, you're going to notice that acceleration difference. That's something to consider. Now, crawler, this is awesome. This is awesome for a crawler. This is generally the KVs that you're running. You're going to be running here. And again, the thing that, yes, the KVs are low, but the Gauss, you're looking at over 2200 Gauss versus 1400 versus 1700. So that's something to consider. This magnet is massive. It's a very strong magnet. So it's something to consider. So this is not a speed demon, but it is a torque monster. Well, I hope this video was informative or at least entertaining. Please subscribe if you have not. Thank you very much for watching, and I'll catch you in the next one.
Oh, my hair! My tongue! My rod!